Okay everybody, welcome to linuxin.com YouTube channel. In today's video we're going to talk about C. So the idea is that C is a procedural programming language and it was initially developed by Dennis Ritchie in the year 1972. It was mainly developed as a system programming language to write an operating system initially. The main features of C language, it include low-level access to the memory, a simple set of keywords, and a clean style. Basically, these features, they make C language suitable for system programmings like an operating system or compiler development. Many later languages have borrowed syntax, features, on several other things directly or indirectly from C language, like syntax of Java, PHP, JavaScript, and many other programming languages are mainly based on C language. C++ is nearly a superset of C language, okay? So there are a few programs that, may compile in C, but not in C++, but that's totally a different story. So if you want to begin programming with the C, you must know that the structure of a C program is different, okay? So we can formally assess the structure of C program. By structure, I mean that any program can be written in this structure only, okay? One in specific structure. So writing a C program in any other structure will lead to compilation error. Okay, so first of all, the structure is you have to have the header files, and then you're going to have the main method declaration, and in that main method, you're going to write your code, and we'll see in a while that how do you do that. Okay, so basically you have the main method declaration, and inside the main method you have variable declaration or something if you're going to have a variable, and then you have the body. The body is something where you're trying to write the code, and finally at the end of the main method, you're supposed to have a return statement. Okay, so yeah, that is the basic structure for C. So that was it for the part of the introduction, and let's move on to the next topic, which is topic number 2, and that is basics of a computer program. So if I were to explain you the basics of a computer program is that you have a high level programming language, you have C, you have a syntax you type in there, and what happens is that the computer, it does not understand that syntax or whatever you're writing. So for example, in C, if you're writing printf and then you're writing hello world, this is my first C program, okay? So something like that, if you're writing that, your computer does not understand that. Okay, so what happens is that you have a compiler on your computer. So your compiler basically compiles the code, the entire code, and then that compiler is going to do what? It is going to execute that code. So by execution, it means that it is going to convert that into the assembly language, or you can say a lower level language, and then that lower level language is going to be converted into the binary language. Okay, so the binary means zeros and ones, and that is basically the language of the computer. And computer does not understand what printf is. It does not really understand what hello world and this thing means. What it really does understand is zeros and ones, a combination of zeros and one. And when the computer gets the combination of zeros and ones, it basically executes that command of yours, whatever you have given through the code, and it would display you the output. So that's kind of how a basic computer program works. I hope you have understand. I have explained to you in detail. If you still don't, ask us in the comments below. We'll try to answer you. Okay, I think we have another C related course on our I think that was 6-hour course that we created from one of the best book I have ever come across. So what I'm gonna do is that I'm gonna put the link in the description. That is a very fairly advanced level of the C programming course. So I wouldn't recommend you to go and watch that course. before you watch this video. Okay, so just watch this video first completely, understand all the basics of C programming language, and then you can basically go ahead and you can watch that 6-hour video content that is present on our channel, and I'm gonna put the link in the description. Okay, so let's move on to the next topic, which is hello world. All right, so what does this mean, like hello world? It's like we are going to run a program. Okay, so the idea is that in order to run your program in C, you have to have like a GCC installed on your system. And how do you know that GCC is installed on your system or not? You just go to your terminal, you press Ctrl Alt T on your Linux machine, and you're gonna write here GCC and then -- version. All right, so you hit enter and you would see the version of GCC on your computer. And right now, if you see on my screen, I have GCC version 8.3.0, right? So this is the main version that we have, and your Ubuntu machine, it comes pre-installed with it. Okay, so by any chance, if you don't have this GCC installed on your computer system, what you have to do is you just write here sudo apt get install, and then you write here build -essentials. All right,
Yeah.
so this is sudo apt get install build essentials. You hit it and then GCC would automatically be installed, but it rarely happens if you're using like the versions like 18.10, 18.04 even, or even 16.04. This GCC thing comes pre-installed with Ubuntu, so hopefully you won't be needing to do that. Okay, so now we have GCC version, right? So now you can write C program in your favorite text editor. You could write it in Atom text editor, you can write it in Notepad++, and by the way, Notepad++, you can see that that's only Windows software. That is not true. We have a separate video on this channel in which we have installed Notepad++, which is a Windows software essentially. We have installed it on Ubuntu as well.
And also, if you want to run your program, or you want to write your C program inside a normal editor like on Linux text editor, or you want to write in a nano text editor, it really doesn't matter. You can write it down. But the thing that really matters is that you run it with GCC. Okay, so you save it with a .c extensions. Okay, so make sure that whatever your file name is, you put .c in the end, so that when you run it with GCC, it knows that it is a C program file and it has to execute it. Okay, so without a further ado, let's go ahead, let's start writing C program. And first of all, what I would do, I would go here and I would open up the normal text editor for Linux. And after opening it up, what I'm gonna do is that inside here, before writing code inside here, I'm going to simply save it. Okay, so I'm going to save it on my desktop, and I'm gonna save it as a first program, or maybe hello.c. Okay, so in fact I could save it like first program.c. all right, so I save it with a .c extension. So now what I'm gonna do, that inside here in this file, first of all, I'm gonna include a library or a header file, as I've explained to you earlier. Okay, in the structure of C program. Okay, so we write here stdio.h, and after that we have a main method, and then we have the body of it, and inside the body we are gonna write the code. Okay, so let's say we write here print f, and inside here we write hello world. And remember that if you are taking our courses, then in the Python course we didn't have any like semicolon at the end of each line, but in C you have to put semicolon at the end of each line. All right, so if you like save it right now, you can see that the colors have changed, which means that it has recognized it as a C program, and this is like basic syntax of C. And finally, as we have discussed in the structure of a C program, we need to write here return 0, okay, or maybe in some cases people write getch method as well, okay. So now we'll save it. In order to run this program or this C program, what we're gonna do is that we're gonna see that where this program resides. So we know that it resides on desktop because that's where we have saved it, right? So now we'll go to our desktop, something like this, okay. We ls here and we see here that we have first program.c, okay. So in order to run this first program C, what I have to do, I have to write here gcc, and then I would write here the file name of the C program, which is essentially first program.c. Then I write here -o, which is a flag for the output binary file, okay. So the idea is that gcc converts the output into a binary file and it saves it in the present directory, and then you run that binary file to get the output. That binary file is essentially in zeros and ones. All right, so let's call it output, the file I'm talking about. So if I hit enter, and now it is compiling the program, and you can see that there are no errors in the program. Otherwise it would have thrown some sort of error if there would have been any error, okay. So right now we don't have any errors, and if we ls here again, you can see that we have an executable file output on our desktop, okay. So what I'm gonna do is that I'm gonna write here output, something like this, and I hit enter, and you can see that we have hello world printed out right here, okay. So if you want to skip a line or so in C, all you have to do is that you have to put a /n here, okay. So you put a /, then you write here n, and then you save it, you go back to your terminal, and now you try to run your program again with this gcc first program.c -o and then the binary file name. You hit enter, and you can see there are no errors. So now after that you write here the output and you hit enter. That was the file name, the binary file name, and now you can see that we have printed out hello world successfully, okay. So that is the pattern of writing a C program, and that's how we're gonna work here, okay. So for the rest of the video, this is your general pattern. We might need to add some header file or something, but for now just remember this is the main theme and main idea, okay. So now let's move on to the next topic, which is essentially variables in C. Then C variable is a named location in a memory where a program can manipulate the data, okay. So this location is used to hold the value of the variable, whatever it is. It could be a string, it could be an integer, it could be a float, character, anything, okay. So we are going to discuss all these data types in the next topic. So if you talk about some rules for naming C variables, then make sure that the variable name must begin with letter or underscore, okay. You cannot begin it with a special character or like with a number. All right, so these variables, they're they are going to be case sensitive, which means that if you have a variable, for example uppercase A, then you cannot really use lowercase a to represent that, okay. So you have to have an uppercase A to represent that specific variable, okay. So these variables, they can be constructed with digits, letters, okay. No special symbols or anything like special characters are allowed other than underscore, okay. So you can only use underscore in it, okay. So if you talk about the declaration of the variable and initialization of the C variable, then I would say that variables, they should be declared in the C program before to use, okay. So whenever you want to use it, you have to declare them before use, because sometimes the C program, it has a concept inside garbage value, okay. So for example, if you have been using a variable for so long, then it might have some garbage value left that might have not been flushed, okay. So what you can do is that you can initialize a variable always, and you can initialize it by assigning a null value, okay. So for a string, it would be like double quotes, okay, that would be a null value, and for the integer variable, 0 would be the initialization step for a variable. Okay, so variable initialization, as I've told you, it means assigning a value to the variable, and that value would be essentially null. Okay, so there are gonna be like three types of variables. One is like local variable, the other one is global variable, and the third one is gonna be environment variable. Okay, so the idea is that we are going to discuss normal variables right now, and then we'll discuss local and global variable later on when we'll discuss functions, because that's when and where it would make most of the sense. Okay, so now what we are going to do is that we are going to write a program. Let me show you how we work with the variable. For example, right here I'm gonna have an integer variable. Let's call it a, and let's give it a value 20. All right, then I put a semicolon here, and I write here integer b equals 25, let's say. Okay, we put a semicolon here. Okay, so these are here one of this is the way to define two variables as well. So also you can do something like this: integer a equals 20, and you put a comma here, and then you write here b equals 25. Okay, then you put a semicolon here. Okay, so that's how both of these ways of basically defining a variable, they are correct, and they are similar. All right, so it's your choice what you want to choose. All right, so I'll comment this. So in order to comment, you put double slash, but I think we have a separate topic on that as well. So now for now I'll just remove it. All right, so now what I'm gonna do is that I'm going to write here a equals we can have another variable c, and we can initialize it as 0. Okay, so that we don't have any garbage value in there. So now what I'm gonna do is that I'm gonna do c a plus b, and then finally I would print f c. All right, so I just write here percentage d for integer, then I'm gonna put a comma here, and then I'm gonna write here c. All right, then I put a semicolon, and now if I save it, if we go back and run our program, so if you dry run this program in your head, dry running means that you compile the program in your head instead of compiling it on your computer. Okay, so we know that we have two variables, a is 20, b is 25. We have initialized c as 0. So now we put c here, a is 20, so if 20 plus 25, the result should be 45, right? And that has been printed out something like this. So the idea is that the logic behind each computer program, it is same. Okay, the only difference we have it is the syntax. Okay, so in Java, the same program you would write in some other way in a different syntax. In Python, you would write the same program in a different syntax, and in Swift or in some other programming languages, you would write this program in an entire different way. All right, so right now if we try to save it and then we go here and we try to run our program, you can see it has compiled successfully and we don't have any errors right now. Okay, so now if we go ahead and if we run our output binary file, we have 45 as the result, you can see. Okay, and we can always put /n to actually give a space of one line, and yeah, that's pretty much it. So we have 45 as a result here. Okay, so now what we want to do is that we want to go to our next topic, and the next topic is data types in C. Then a data type in C programming is a set of values and is determined to act on those values. Okay, so C provides various types of data types which allow the programmer to select the appropriate type of the variable to set its value. So the data type in a programming language is the collection of data with values having fixed meaning as well as characteristics. Some of them are an integer, floating point, character, etc. Okay, so the idea is that in Python you have like you don't need to define the data type of the variable. Simply you just put in the variable name and then you store the value in it, and it automatically identifies the data type and converts itself into that specific data type. In C, that is like entirely different. You have to specify the data type. So for example, if you're going to have an integer value, what you're going to do is that you have to define the variable as integer. Okay, if you don't define that, it would but it would for sure give you an error, because you have to define a data type. And for example, if you try to store any other data in one specific data type, for example, if you try to store string in integer, it would also cause you an error and your program will stop running. So basically, C data types, they are used to identify the type of a variable when it is declared, as I've told you, and it identifies the type of the return value of a function as well. It could identify the type of a parameter expected by a function as well. Okay, so in Python functions we have seen, I'm talking about the course that we have created. We'll put the link in the description, or you can just go on and you can watch it on our channel. We have created the same course for like 3 hours plus course for Python as well on this channel, so you can go and take a look on that as well. Okay, so if you talk about the declaration of the primary data types, then you also have that. Okay, so there are some of the data types that are like predefined, and some of the data types which user can define. Okay, so the idea is, let me just go here and let me just show you. So here we have the integer data type, right? And we can also have float data type. Okay, so if we write here float, and we can write here b, all right, and we can have here character, and we can call it like C, let's say. Okay, so these are the three data types that we have here. So we have other data types as well, like a long int and long and short and double. Okay, so these are just the modified or advanced versions of integer and float. Okay, so I hope you have got the point. So now we also have the size of integer, and we also can figure out the size of character as well. So the idea is that character, it can only have one alphabet, and string can have multiple characters. Okay, so that was it about all the data types in C. Another data type that we have, it is double. Okay, and the double, it is used to store decimal numbers. So double, it stores the decimal numbers with double precision, while float, it is used to store decimal numbers with single precision. Okay, and if we talk about integer, as the name suggests, so an integer variable is used to store only an integer. Okay, and if we talk about the character, it is the most basic data type in C, and it stores a single character and requires a single byte of memory in almost all compilers. Okay, so different data types also have different ranges up to which they can store numbers. These ranges may vary from compiler to compiler. So the short integer, it has like the range of -32,768 to +32,767. Okay, so these are the kind of ranges. You can literally figure it out quite easy. So right now we have integer as a, which is equals to 20. We can have, let me just remove all of that. Okay, we have 20, and then we can have, let's say, character b. All right, and let's give it a character as, it could be any alphabet. So let's say we have here a, we put a semicolon here. Now we go to the next line, and we have double here, let's say, and double is gonna be like up to 2%. Okay, so we're gonna write here 3.14 maybe. Okay, so now we have that. All right, so after that we are going to print the size of the character. So for that, what we're gonna do is that we're gonna go here and we're gonna write a printf statement. All right, and printf. Okay, and in here what we do is that we write here %c for the character, and we %c has a size of and then we write here %lu bytes. Okay, so we write here b for character because %c stands for character, and then we use the size of method, size of, and inside here as an argument we pass the character. Okay, so once we have done that, now what we are gonna do is that we're going to have a printf statement. Okay, another printf statement actually, and right now we're gonna talk about the integer size. Okay, so now if we have here, like, let's say printf again, and in here we're gonna have %d for integer has a size of %lu bytes. Okay, so put a comma here, we have a here, and then we're gonna write here size of, and inside here we're gonna pass the data type, which is essentially integer. Okay, then we put a semicolon here to end the line, and now we are going to come here, we're gonna write here printf, and we're gonna write here percentage, for double you usually have a %lf. Okay, and then you write here has a size of %lu. all right, and then you're gonna write here lu bytes. Okay, so remember that you can always put here a /n to separate it, and keep it on the next line always. All right, with a /n. And now you need to write here the variable name for double, which is essentially c. Here you put a comma here, and then you write here size of, and then you have brackets here, and then inside the brackets you write double. Okay, so then you put a semicolon here as well. All right, so now we are all done, except we just need to write here return 0, which is essential. And we save this program, and now let's go ahead and let's check the size of each character. Okay, character or the variable, integer or the double. All right, so we go to our terminal and we try to run our program, and we run it, and you can see that we have some sort of error. Okay, we need to write here return 0. That I forgot to write. I'm sorry about that. So we save it. Let me just clear it, run our program again, and now you can see that there are no errors. Okay, so now if there are no errors, what we need to do is that we need to run our binary file, which is essentially output, and you can see that it says a has a size of 1 bytes, which is a character, and integer it is 20, it has a size of 4 bytes, and 3.14 which has a size of 8 bytes. Okay, so that was the thing related to the size of the data types. All right, so now let's move on to the next topic, which is essentially numbers in C. So the idea is that as any other programming language, you have like numbers in C, as we have been working with it. So let's say we have integer a equals 60, and we have integer b equals 20, and then we have the sum of it. which would be equal to 0. We initialize it, and we basically get a product of it as well, which is like multiplication, and that is equal to 0 as well. Is that we come here, we write here sum equals a plus b. All right, and we come here, we write here product, and we set it like a static b and then semicolon. Okay, so now if you take a look here, what we've done, that we have two variables, integer a and integer b. A is equal to 60 while b is equal to 20. Okay, so if we add both of them, 60 plus 20, that would be 80, and 80 would be stored in sum. And if we talk about the product, and if we multiply 60 by 20, we're gonna get the result 1200. Okay, so now what we're gonna do is that we're gonna go here, and in here we're gonna write here printf, and after writing printf, we write here percentage d, and percentage d is the sum. Okay, and we write here a comma, and then we write here the variable, which is essentially sum. So in the similar way, we write the same statement for product as well. So we write here percentage d, and we write here is the product. All right, so then you write here slash n, you write here slash n as well, and then after that you put here a comma, and then you write here product. Okay, so you put a semicolon here as well, and now we are all done, except we just need to write here return 0. We did not write the data types with the sum and product. Okay, so in some programming languages you won't be needing to write the data type, but in C, as I have mentioned earlier, we need to write that data type. That is essential. Okay, so we run our program, you can see that there are no errors. So now if I run my output file, you can see that it says 80 is the sum and 1200 is the product. Okay, so you can do anything with the numbers, it totally depends upon you. So without further ado, now let's move on to our next topic, which is strings in C. So the idea is that strings are defined as an array of characters. The difference between a character array and a string is that the string is terminated with a special character. Okay, and that is like slash and null. So the idea is that the declaration of strings, that is like sort of different. Okay, so declaring a string is as simple as declaring a one-dimensional array. So a string, it does not have a data type in C. So the idea is that you basically have a character array and you use the string in it. Okay, and if we talk about the initialization of the string, a string can be initialized in multiple ways. Okay, so we have you can specify the size of the array, and then you can have curly braces, and then you write the string character by character. That would work fine as well. You can specify the size of the array, and then you can put different values in it. That would be okay as well. So let me show you in the code that what are the multiple ways of basically doing the same thing. Okay, so let me just keep this return 0 here, and let's say that I want to work with strings. So all I have to do, I have to write here character, and then I could write here the variable name, which is essentially str. I can define the size, or I cannot define the size. It totally depends upon me. Okay, so I say Linux hint, and this is a string, so I put a semicolon here, and C, it does not give you the string data type, but it for sure gives you a specifier such as like %s in order to keep track of the string and print it out directly. Okay, so what we're gonna do is that we're gonna write here we have character string and we have a Linux hint, and now what we're gonna do is that we're gonna write here printf, and inside the printf I'm gonna write here
percentage s, and then we're gonna write here a comma. And after writing a comma, I'm gonna write here the variable name, which is essentially str. So I save it, and now I go back here and I run my program. It does not give us any error. I run the output file, and you can see that we have Linux hint on the output, right? So what else we can do? We can define the same thing with a size as well. So for example, I assign here a size to the array I'm talking about. If I assign here a 50 size, all right, so it would work because it has 1 2 3 4 5 6 7 8 9. Okay, so it has like 9 character. Okay, so I have basically defined an array for 50. Okay, so that would work fine as well. And if you don't mention the size, it would automatically adjust the size of an array, and it could be as long as you would write here. Okay, so here 50, it is like a specification of the size of the array, which means that this value must not exceed 50. Okay, so now if we save this thing, if we go back here, try to run our program, would essentially get the same result. Okay, so there is another thing that we can do, and which is that you can basically use that null specifier or that null character and actually make a character array which would be considered as a string. So if I would just write here character str, and then after that I just simply write here brackets or curly braces, and then I could have here character by character. I write here L, put a comma here, I write here I, put a comma here, I write here N, put a comma here, I write here U, put a comma here, I write here X, put a comma here, I write here single quotes H, put a comma here, I write here I, put a comma here, and then I write here N, I put a comma here, I write here T. So this is like sort of Linux hint. All right, so what I can do, I can save this thing and I'll keep it that way, the print statement I'm talking about. So we'll just simply go back to our terminal. Let me just clear it, and I go here, I run my program, and you can see that there are no errors. So I run my output file, and you can see that I have the same result. Okay, so this is like the third way of basically defining a string. All right, so there's another thing that you can do, is that you can put a null character to tell that this is the end of the string. Okay, so you have to write here / and then you write here 0. All right, so we save it, we go back, we run our program again, it compiles successfully, no errors, and if we run our program, we get the same output. Okay, so you can also specify the size here. So let's say I write here size 10, I save it, I go back, I run it, and then I run the output. You can see that the size is like complete, and we've got Linux hint. So what if I decrease the size to, let's say, 3? Now obviously I know that the characters are more than 3 inside the array, so let's see what happens. So it gives multiple errors, right? And the errors it is giving because the problem is in initialization. Okay, so it says excess elements in array. Okay, so what we can do is that we can increase the size to avoid this error, and if we now run our program again, we have no error, and that's how we'll get the output. Okay, so that was all about strings in in C program. I hope you have enjoyed it. You have learned something new regarding strings. So now let's move on to our next topic, which is essentially comments in C.
Okay, so now let's move on to the next topic, which is topic number 8, and that is related to the comments. Okay, so a comment is an explanation or description of the source code of the program. Okay, it helps a developer explain the logic of the code and improves program readability while someone else is reading it. Okay, so at runtime, a comment is ignored by the compiler. Okay, so there are two types of comments in C. A comment that starts with a slash asterisk and finish with an asterisk slash, and you can basically place it anywhere in your code on the same line or several lines. Okay, so we also have single line comments which are like with double slash. Okay, so the idea is that comments are necessary because, for example, if the developer has written the code and if someone else is reviewing the code, or maybe some other developer or tester, they could read the comments, which is like sort of a description of the source code, and they could understand that what the original developer has used the logic or stuff, and they can actually make a change or improvement in that code. That would be quite easy for them. Okay, so the compiler, it understands that the comments are for the description, so compiler would automatically ignore those comments. Okay, so without a further ado, let's go ahead and let's do a little example of that. So for example, we have it here. So right now, if I write here something like this is a C program, okay, so which deals with strings. All right, so if I have that, then what would happen is that if I save it, I go back, I try to run my program, then it would give me an error. Okay, because it doesn't recognize this syntax. So if I do something like this, it would make it it would comment it and it would ignore it while compiling the code. Okay, so now if I try to compile again, you can see that it has not given me any error because it has been commented. Alright, so what if I want to have multiple lines? And remember that the comments could be made like anywhere in the code. So for example, here if let's say if I want to have the comment, so let's say I have it something like this. All right, so we have multiple lines of the comments. So what I can do is that either I can write here double slash one by one, but let's say if you want to comment 1,000 lines, then it would be difficult. So for that we have slash and asterisk. Okay, you can see that everything has been commented, and where you want to end the comments, just put asterisk and slash there, and you can see that the color has been changed from here and it could now work. So if we save it again, we go back here, we try to run it, the program, you can see that there are no errors and these comments have been ignored. Okay, so two ways, one double slash and the other one is slash asterisk and asterisk slash. Alright, slash asterisk and asterisk slash is for multiple lines, while double slash is for a single line. Okay, hope you've got the point. So now let's move on to the next topic, which is getting user input. So you can take an input from the user and then perform different actions on it. So for example, we go here, we try to write different code. So we'll just remove this. All right, and inside here we can have an integer variable, let's call it a, and then we're gonna have another variable, let's call it b, and then we have a printf statement which says enter number. All right, so we can say enter an integer number, or we can say enter your age. Okay, enter your age, and instead of having like integer b, we just have integer a, and after writing here enter your age, we can have like a colon here, and after that we come to the next line, and here we use another built-in method called as scanf that is used to scan the input from the user. All right, so we just write here %d for integer, and then we put a comma and we write here the variable name in which we are going to store the input. Okay, so we just write here ampersand sign, and then we write here the variable name, which is essentially A. Okay, so after that, once we have taken the input, now what we can do is that we can write here printf, and we can write here your age is %d. All right, so that could be a very good example of taking an input. And after that, what can I do that in order to match the %d sign here, I'm just gonna put in here A, and I put here a semicolon, and we are done. So now if we save it, and if we go back here, we try to run our program, you can see that there are no errors. So now if I run my output file, and you can see that it says enter your age. So I add here 24, and it tells me your age is 24. Okay, so what else I could do with that? So we can also take the string input, and we can work with that as well. So for example, so the idea is that if you want to take the string input, then in that case it is a little bit different than a scanf. Okay, so it has been scanf with regarding to string, it has been depreciated. Okay, so for that we have a new method fgets that is like really cool, and it works fine as well. So we can take that actually and use it. All right, so what we can do is that we can have here the name of the user. So for that we would define a character array. So we write here character name or character str, whatever you want to call it, and you want to assign it a size of, let's say, 50. And then after that, what you can do is that you can put a semicolon here, all right, because that is a part of the syntax. And after that we can write here the print statement. So we'd write here printf, and then inside here we'd write hi, enter your name please. All right, then I put a colon here, I write a semicolon here, and then after that I'm gonna have here, instead of scanf and doing something like this, like let me show you %s, and then instead of writing here name, this is basically you know, it is old school, old fashioned, so it doesn't work anymore. So that's why I've commented it. Instead of that, what I'm gonna do, I'm gonna have here the fgets or fputs method. Okay, so we are going to have here fgets. Okay, and as the first argument in fgets, I'm gonna pass the name of the string, which is essentially name, and then I'm gonna pass the size of it, which is essentially 50 here, and then I'm gonna write here stdin, which means standard input. All right, then I put a semicolon here. So now I could basically use it wherever I want. So after taking the name and after taking the age, and the name is stored in name array, name string array, and the other one, you can say the age has been stored in the integer. Okay, so this is a character array basically, and we are using it as a string. All right, so now we can write here two things inside one print statement. We can say your name is %s and your age is like this. All right, so then we can have here because we have %s first, so we'd write here the name array first, and then we'd write here comma, and then we'd write here a. Okay, so I hope you've got the point. So there was nothing difficult in this code. First we have defined an integer, then we have defined a name, and then this is the character array named as name, and then we have printf statement. It would just print out hi, enter your name please, and whenever the user would enter something, it would be stored inside this name character array. And after that we have printf again. So this is like enter your age, then the user enters its age, and the age gets stored in the variable a. All right, and then finally we print out the name and the age respectively without any difficulty. Okay, so we have used the variable names as well here. And then finally, return 0 is the convention. Without it, your program throw an error. Okay, so we save it, we go back to our terminal. Let me just clear it. We run our code. There is no error, so we run the output binary file. So it says enter your name here. So I enter the name and then I enter the age, and you can see that it says your name is Talha and your age is 24. Okay, so that's how you basically do it. So now what you're gonna do is that we are going to move on to our next topic, which is essentially constants. Alright, fine. So C constant is the most fundamental and essential part of the C programming language. Constants in C are the fixed values that are used in a program, and its value remains the same during the entire execution of the program. So constants, they are also called as literals. Constants can be any of the data types, and it is considered best practice to define constants using only uppercase names. Okay, so you can define them with lowercase as well, but it is best practice to define them with the uppercase letters. Okay, so the general syntax is you write constant, const, and then you write the data type, and then you write the variable name, the constant variable name. Okay, so let's do a small example to understand it. So for example, we're just gonna go here and we try to write here constant integer, and then we write here the variable name. Let's call it height. All right, and we keep it equals to, let's say, 10. All right, and then we have the integer width, let's say, and we don't keep width constant, and we say, let's say, 20. Okay, and then after that we define another variable which we call integer, and we call it, let's say, total. All right, so we initialize it as well. All right, so now what we're gonna do is that we're gonna write here, let's say, total. We write here equals, and we multiply that height static width. All right, so after that what we're gonna do is that we are going to have so now what we're gonna do is that we're going to have a printf here, and in here we're gonna write here the total is %d, and the height is %d, and width is %d. Okay, so we go here and we write here total first, then we write here height, and then we write here width. Okay, according to the values that we want to print. So now we put a semicolon here. We are all done, and after putting a semicolon we come here and we write here the final line which we always write, and that is return 0 essentially. So now we save it and we go to our terminal and we try to run our program. You can see that there are no errors, and if we try to run the output file, you can see that it says the total is 200 and the height is 10 and width is 20. Okay, so yeah, that's pretty much it. But in here you can see that if we try to change the width, we can do that. So for example, if just before getting it multiplied, if we do something like this, width equals, let's say, 10. Okay, now the instead of total, instead of being 200, it would be 100. All right, so we do that. We go here, let me just put a /n here to go to the next line, and we save it. We come back here to our terminal. We try to run our code.
you can see that there are no errors. We run our binary file and you can see that it says the total is 100 and the height is 10 and width is 10. Okay, so now let's try to change the height as well and let's see what happens. Okay, so we just write here height and then we write here instead of 10 we write here 20 and let's see what happens. The answer must be 200, but let's see if it compiles it. But you can see that it is giving us an error that you cannot really change it. The assignment of read-only variable height is, it's failed. Okay, so you cannot really change the constant variable, and the the assumption is that you always define them in capital letters. That's what you've got to do. Okay, so that was like just as a convention. All right, you define them in capital letters or uppercase. So that was it for constants. I hope you've got the point. So once you have defined the value of the constants, you can not really change it. Okay, so now what we're going to do is that we're going to move to our next topic, which is essentially if statements. So now we have if statements to work with in C. So what we're going to do is that we're going to write some practical code and understand the if statement. So the idea is that if condition it's nothing but it's just a representation of putting a condition on the code. So for example, if you want a specific code to be executed but it has some special condition, like you want the input to be equal to a certain number or a certain amount, you can put a check on that, and that code, specific code that would be inside the if block, it won't be executed until a specific condition that you would put, it must be satisfied. Okay, so that's what we're gonna do in today's coding. So let's say we have integer a. Actually, I'm tired of naming the variables like a and b, so let's change it. So integer x equals 19, and let's say integer y equals 23. All right, so these are the two variables and they have their own value. So now if I put something like this, if x double equals y, then in that case what I want to print here printf. And remember that in Python the indentation was necessary, but in C there is no need to do indentations and stuff. It would perfectly work even without indentation. Obviously your readability of the code would be affected, but the execution won't be affected. All right, so C doesn't take indentation very seriously, so your code could be unindented and it would still give you the output. All right, so for example, if I have something like brackets here, I could literally have the bracket here and it won't make any difference. All right, so now what I'm gonna do is that I'm gonna write here the x and y are equal, and we put a semicolon here, so we put a condition, and this this printf won't be executed until and unless x and y won't be equal. Okay, so we know that x and y, they are not equal, so we can have an else block here. An else block executes when the if condition is not satisfied. Otherwise, if there is no else block, if condition would be left behind and the cursor would move on to execute whatever code is in the other block. Okay, so right now we're gonna have here a printf statement, and we're gonna say that the x and y are not equal. Okay, so we write that, we put a semicolon here, and then after that, after the else block, we write here a return 0 statement. We save it, we go back to our terminal and we try to run our code, and you can see that there are some errors, and the error is that I think we have we have put a square bracket by mistake here, so we'll just save it. We go back to our terminal, let me just clear it, we run our program, and you can see that there are no errors. Okay, so now if we try to run our output file, we get this: the x and y are not equal. All right, so the else block has been executed because this condition was never satisfied. All right, so we can put a slash n here, and we can put a slash n here as well. Another thing that you can do is that you can make them equal. So for example, we make them equal to 23 and we save it. We go back here, we try to run our code, and you can see there are no errors. So now if we try to run our output file, you can see that it says the x and y are equal. All right, so they are equal, and that's why the this condition was executed. All right, so there are several things that you can do. Is that one of them is that you can check if x is greater than y, and you can see that they are both equal. All right, so if we save it, we go back here and we run our code, we run our output file, you can see that it says the x and y are not equal, right? So if we put an equal sign here, is greater than or equal to, in both the cases it would be true. So we run our code and you can see that there is nothing wrong with that. The x and y are equal. All right, so what we can do is that we can do something like this as well. Less than x is less than y, and if we save it, in here we can write the x is less than y. Okay, the x and the x, let me just write here, the x is less than y or equal. Okay, or equal to y. So we save it and we just try to run it, and right now you can see that there are no errors, but it says the x and y are not equal. Okay, the else block has been printed out. So now if we do something like this, and if we go back here, try to run our code, you can see that it says the x is less than y or equal to y. All right, I hope you have got the point. And there is another thing that you can do actually, and that is basically you can have and or condition as well. So for example, I have here z equals 30, and I can have here multiple conditions. Say I write here x and y, and I call it like x less than y, and then I can have here and condition, and then I can have here another condition which could be like x is greater than, or z is greater than x. Okay, so now let's try to run this code and let's see what happens. We have an I think we have an indentation, we have brackets error. So the idea is that you need to enclose all of that in one big bracket as well. So we save it, we go back, we run it, and you can see there are no errors. So now if we run the output, you can see that it says the x and y are not equal. It has executed the else block. So what we're gonna do is that we're gonna write here that both conditions are true. Okay, so in the else block we can write here both conditions are not true. Okay, so we save it, we go back to our terminal, we try to run it, and right now if we run the output, you can see that it says both conditions are not true. And why it is not true? Because x is 23 and y is 23, so this is false. And if we see z is 30, it's greater than x, so this is true right now. But still, we didn't get the results, right? So if we just make x greater than less than y, let's say we make it 20, and we have y as 23, we have z as 30. So let's say right now this condition is true, but we try to make this one false. Okay, so what we do is that we create we make z like 10. All right, so we save it. Now we know that 10 is not greater than 20, and obviously 20 is less than 23, right? So this condition is true now, and this one is false. Previously this condition was true and this one was false. All right, so now if we save it, let's see what happens. So we run our program, and then we run the output binary file, and you can see that it says both conditions are not true. Okay, so one more thing that you could do is that now we are gonna create something like this, and now both conditions are true. 30 is greater than 20 and 20 is less than 23. Okay, so now which part would be executed? This if block, and we would have both conditions are true. Okay, so we go to our terminal, we run it. Let me just clear it, and then we have the output binary file, and it says both conditions are true. Similarly, we have a double pipe sign which stands for or. It means that one of the conditions have to be true. Okay, so it could be like even if the both conditions are true, it doesn't matter. If block would be executed, and if even if like one condition is wrong and one is true, it would still be executed. The only condition when it would not be executed is when both conditions would be false. Okay, so for example, right now we have both conditions true, so we can write here actually at least one condition is true. Okay, so now what we're gonna do is that here we can have both conditions are false. Okay, so right here we save it, and now what we're gonna do is that we're gonna go here and we try to run our program, and you can see both conditions are true, so it says at least one condition is true, right? So let's make it false intentionally. We say x is greater than y, which is false, but still you would see that it would give us an output, at least one condition is true, and that one is z. All right, so now try to make both of them false intentionally. So now z is 30, 30 is not 30 is less than 20, this is false, and then we have x is greater than y, 20 is not greater than 23, and that is false as well. So now both of them are false. So what we do, we save it and we go back, we try to run our program, we run the output binary file, and you can see that it says both conditions are false. Okay, another thing that you could do is that you can have an if condition inside the if condition. That is called as nested if condition. Okay, so for example, here we're gonna have if x is greater than y, okay, or if x is less than y, then in here we also going to have an if condition in which we'd say z is greater than x. Okay, so it's similar to the and statement. Okay, both of them have to be true, then in that case it would be executed. Okay, so we can have a body of it as well, so we'll just make a body. So we'll just go here, we basically have a bracket here as well, and this is the if bracket, and there is no need to indent the code, but if you want to, there is no problem with that as well. So we have here printf, and here we can see we can in fact write here true, and we can write here true as well. Okay, printf, and we can say x less than y. All right, and here we can say z greater than x. Okay, so this is basically nested if. All right, so now you see that if both of them would be true, they would execute. Okay, so we'd have the result. So if we run this and we go to output, you can see that it says x less than y and z less than x, z greater than x, excuse me. So both of them have been executed. All right, so let's just run it one more time so that you're able to see clearly. X less than y, z greater than x. So both of them have been executed. So now let's make one condition false intentionally, and now if we save it, we go back here, we try to run it, and you can see there are no errors. We run the output file, and you can see that only one condition has been true, and now only print statement here we have it x less than y. All right, and we don't have this z greater than x. Okay, so I hope you have got the point here. So now what we're gonna do is that we are going to talk about else if condition as well. Okay, so else if is something like, you can have here else if that you're giving it as a chance. So we just, let me just remove this thing from here, and we can have here else if z is greater than, it's like or. Okay, that was nested if was like and this else if is like or. So now what we can do is that we can write here print, and we can write here z is greater than x. Okay, so now you can have else block here, else, and we can say print f here, and we can write down here that none of the conditions are true. Okay, so we write here /n, and we write here a semicolon, and now if I save it and I go back here, I try to run my program, and I run the output, and it says x less than y. Okay, so that is true, x less than y, and z is greater than x. So you see here, you notice here that right now it only executes this one, and that was true, so it ignores everyone. Okay, so what we can do is we can intentionally make it wrong, and then you would see that it would basically go to the else if block, and it would execute that. So now if we try to run it, and if we try to go to the output, z is greater than x. Okay, so z is greater than x. Now we have this. Okay, z is greater than x, and this one was true, so it came here. It wasn't true, so it didn't execute it. It came here, it was true, so it executed that. Okay, so now let's make this one false as well, and now let's go ahead and let's see what happens. Okay, so let me just clear it. We run our program again, and we run the output file. You can see that it says none of the conditions are true. It comes here, it was false, it didn't execute it. It moves on, it comes here, it wasn't true as well, it was false, so it ignores that as well and execute the else block. Okay, remember when both of them are not true, it is going to execute the else block. Okay, if there is no else block, it would move on in the coding, and it would execute the rest of the code. So if condition I have explained to you in detail. We have discussed nested if, if, else if, and or conditions, and we have discussed else block as well. I hope you have got the point. You have learned that in detail. If you have any questions about else, if else thing like in C, you can ask that in comments below. Alright, so now let's move on to the next topic, which is related to the loops. So for loop. So the idea is that for loop, it has a syntax. And let me just write down a syntax for you, and then I'll explain to you that what it actually does. All right, so let me just remove all of that, and let me just write here for loop, and then here this one is going to be initialization statement. So let's call it integer I equals 0, let's say. And then we're gonna put here a conditional statement that is gonna be, let's call it I less than 10, and then we are gonna update I, and that would be I plus plus. Then we have the body of the for loop, and inside the body you could write like anything. Okay, the indentation in C is not really necessary, so we just write here %d maybe. And then we basically write here I, which is essentially the variable. And here this is just a small example. So the first thing here that you see I equals 0 in this portion, it is the initialization statement. All right, then we have this conditional statement or test expression, and then obviously we have to update the statement that we have initialized. Okay, so the idea is that if you say that how loop works, the initialization statement is executed only once, and that is I equals 0. Okay, so now it will not be executed once it has been executed. Okay, so after that the test expression is evaluated. If the condition is true, it would basically go on to run the loop. If the condition is false, it would break out of the loop. Okay. So however, if the test expression is evaluated to true, statements inside the body of our loop are executed and the update expression is updated. Okay, this I plus plus. After that, the expression is again evaluated and then the same procedure is repeated. Okay. So this process, it goes on until the test expression is false. When the test expression is false, the loop terminates basically. Okay, so this is here we just have a simple example. We have initialized the I. Remember that you can always define I outside the loop as well. If you define it outside, it would be a global variable. If you define it here, it would be a local variable. Okay, so the discussion that we were actually having here in the variables in C, we can do that here in for loops. Okay, so right now if I want to access this I can only access it inside the for loop because I is initialized and defined it right here. Okay, so if the I would have been defined here, I not only would have been able to access it inside the for loop, I would have been able to access that I outside the for loop as well, which means that it would have been a global variable. Okay, so that is the difference between local and global variables, and I would show you in a while as well. So right now if I save it and if I go back here to my terminal and I try to run this code, so you can see there are no errors, and if I run the output binary file, I have the output as 0 1 2 3 4 5 6 7 8 9. Okay, so what I can do, I can have here /n to move it to the next line, and I try to execute it again, and after that I can run the output binary file, and you can see that from 0 till 9. Okay, so it has not printed out 10 because 10 is not less than 10. The condition was false and the loop was terminated. Okay, so it printed out till 9 because 9 is less than 10. Yes, true. It executes it. Alright, so one more thing, that if you try to access this, now I'm talking about local variables and global variables. So this is a local variable, we know it because it has been defined inside the for loop, and if I try to access it like outside the for loop, in the end, so let's just say that I did not have any print statement here, and I just have a print statement here, and obviously I say %d here, and then I try to define it, I try to use I here, I put a semicolon, I save it, I go back to my terminal, try to run it. Alright, so when I run it, you can see that it is giving me an error, and it says that I is undeclared. Somehow it is telling me that you're using I and it is undeclared, while that is not the case. I is declared, but it is inside the for loop. Alright, so what I can do is that I can declare the I outside the for loop. Let's say if I declare it right here, integer I equals, let's say I just define it. Okay, so I define it here. So now what would happen, that it would basically assume it as a global variable, and now it would be able to access it right here, and here it would have the value of I only once because it is outside the for loop, and the last value when the loop was terminated would be stored in the I variable, so it would print it out here, and that would be essentially 9. So we save it, we come here, we try to run our program again, there are no errors, so let me just clear it, then I run my output file. Here I hit enter, and you can see that we have 10 right here. Okay, so right now white had 10 actually. Yes, the reason it had 10 because the value here after the increment, it had become 10. So when it checked it, 10 is less than 10 or not. So it didn't execute anything inside the for loop, but when we go outside the for loop, the value of I is still 10, and that's why we have got 10 here. Okay, so I hope you've got the point. So another way to testify this is that if you put it equal sign here, so now when 10 is equal to 10, that condition is true, it would go inside the for loop and it would break the for loop on 11. So I would have 11 and here we would have 11 as well. So let's save it. Let's go ahead and let's try to run our code, and you can see that there are no errors. So we just go here, we run our output file, and you can see we have 11 here as a result. So yeah, that was it for local and global variables. I hope you've got the concept. The concept is very simple, that the local variable, it can only be accessed locally, while the global variable, it can be accessed anywhere. It can be accessed inside the for loop as well, okay, as well as outside the for loop, because it is a global one. All right, so now let's move on and let's try to do another example. So for example, if you want the loop to run indefinitely, like for example, if you want the loop to run multiple times or infinitely, okay, so you can do that as well. So how do you do that? I would have to close the terminal, because unlimited loops, till infinity, so these loops would keep on running. So you just put semicolon here and you have it like this. All right, so now this loop would run infinitely, okay, so the number would keep on counting. So we just go here, we try to run our code, there are no errors, and if we try to run it, you can see that it's running. We have 0 and it's printing out 0 like anything. Here you can see. So what I have to do, I have to press Ctrl Z to go outside of it, otherwise it would keep on printing it. And if I scroll up here, I cannot tell you that how many zeros it have put here, something like this. This is an infinite loop, right? So it would have run till infinity, so I had to stop it. All right, so I hope you've got the point. So now we can do a more complicated example regarding for loop. So what we can do is that we can have here these condition, and in here we can have an if loop, and inside the if loop what we can have a condition. If I is less than 5, then print out this, otherwise don't print anything. And one more thing, that if you do not put any brackets with the if body, if you have only one line, you don't really need to put brackets. It would consider it the part of the if, okay, because there is one condition for if, and that is that it has to have one statement at least in its block. So this statement without brackets, it would be considered the part of if right now, okay, even if we don't put the if body brackets right here. So now if we save it, we go back here and we try to run our code, there are no errors. And if we run our output file, you can see that we have 0 1 2 3 4, okay, so these are the values that we have, and that is it. All right, so I hope you've got the point. So you can say that why it didn't print out till 10, because we had an if condition here, and as soon as this if condition became false, it didn't print out anything, because only print statement is inside the if block, okay. So the loop would have been running, but this condition would have become false, and that's why it was not like letting if do anything, okay. So I hope you have got the point. You have learned something new regarding for loops. So now let's move on to the next kind of loops, which is like while loop. So as we have discussed in programming, there are like 3 kind of loops. One is for loop, the other 2 are while loop and do while loop, okay. So previously we have discussed for loop, and now we are going to discuss the while loops, okay. So the while loop, it evaluates the test expression or the conditional statement inside the parentheses. If the test expression is true, statements inside the body of the while loop are executed, okay. So let me show you that how to write a while loop and what it does actually. So let me just remove all of that. So we'll keep the integer I thing here, and after that we are going to have a while loop, which would actually work with this I thing. Okay, so we just initialize this I right here and we put it equals to 1, and then we have a while loop here, and inside the while loop what we're gonna have is we're gonna have a condition here. Okay, so we write here I is less than equals to, let's say, 10. Okay, then we have the body of the while loop, and inside the body what we're going to do is that we're going to write a code. Okay, a piece of code. So let's say that if if we print it, okay, simply, so we write here printf, and then we write here %d, and then we write here /n, and then we write here comma, and then we write here I. Okay, and after that what we're going to do, we're going to put a semicolon here, and we're going to come down here, we do I++. All right, so we do I++, and after that we come down here, and here what we're going to do is that we're going to write return 0. All right, so we are pretty much done here. So I is equal to 1, and this loop is gonna run until this condition becomes false. Okay, so when I would become 11, this loop would terminate and it would come out and execute this return 0. Alright, so I hope you've got the point. So we save it, Control S, we go back to our terminal, we try to run it. Okay, so we run this thing and you can see that it is giving us an error. So what we have to do is that you need to make sure that they are like this, okay, and not like this. So we save it, again we go here, we try to run our code, and you can see that there are no errors. So now we run our output binary file, and you can see that it has printed it out from 1 till 10. The only difference between while and do while loop is that in while it first checks the conditions and it executes it, while in do while loop it first executes the condition, the block, and then it checks the condition. So for example, if the first time the condition is, let's say, false, so if I just write here if I is less than or equal to 0, in that case this condition won't be executed even once. But in do while loop you would have do first here, then you would have the body, and then you would have the while loop. So in that case it would execute this condition at least once, right? So even if the condition is false, this block still be executed once. Alright, so I hope you've got the point. So right now if I save it, the condition is totally false, and if we go here, we try to run our code, it runs fine, but we won't have anything on the output. You can see that we have not got anything. So if you consider it like doing the same thing with the do while loop, it would result in the same thing as I've told you. Okay, so let's try to do that as well. So if we write here, let me just put this condition down there, and I just write here do, and I put this condition right here. Now this condition is false, absolutely, you know that, right? So I forget usually, but make sure that you do not forget it, because when you will be working with large programs, these mistakes like semicolons, they could be really pain, so just save it, just go back here and try to run your code. There are no errors. So now we write here ./output. You can see that it has been executed at least once, and we've got 1. But in the while loop we didn't even get anything. Okay, it didn't execute it. But in do while loop it executes it first, then it gets to the condition is false, so it actually breaks the loop. But when it is breaking the loop, it has been already executed once. Okay, so let's make it 10 and let's save it, and let's go back and let's try to run it again. Okay, so now if we run it and we run the output file, you can see that we've got till 10 because the condition 10 was true, and these are the results that we have got. Okay, so one more thing is that the while loop and the do while, they are almost the same, but there is just one difference, that if the first condition while running for the first time it is false, while loop would not execute its block, while do while loop would execute it only once, okay? At least once it has to be executed even the condition is false. All right, so I hope you've got the point. You've got the concept about while and do while loops. I can literally write anything, any example of the code in here. I mean, I could put if conditions inside the a while loop as I've done in the for loop, but I would leave that on you. Do it yourself and make yourself familiar with C language. It's very easy. It's really fun to do programming in C language. It's basic, it's understandable, it's easy. If you understand C, you can literally understand any other programming language. They won't be a problem for you. Okay, so I hope you've got the point. So now what would I do is that I move on to our next topic. We have done for loops and we have done while and do while loops as well.
Okay, so now let's talk about arrays. Okay, in this tutorial, obviously we have been talking about C programming, and arrays is actually a crucial part in C. So basically, an array is a variable that can store multiple values. Okay, so recently we had worked with variables where we would be able to store only one value in one variable, but in arrays you can store actually multiple values in one variable, as we have done it in, I think, when we were talking about strings in C, we have done it. So the idea is that the syntax of defining an array is like you define a data type, like for example integer, float, then you have the name, then you have the brackets, the big brackets or square brackets, and inside that you have array size. Okay, you specify that. So right now if I go to my C program, and if I were to show you that how to declare an array, let me just remove all of that. First we're gonna have the type of the array. So let's say that the type of the array is float. Okay, so let's say the name of the array is array1, and let's say the size of the array is 100. Okay, so that's how you basically declare an array, and you can access the elements of an array by indices or by indexes. So suppose that you declared an array array1 and with 100 size. So now let's say that 0 is the first index on where you can actually store a value. Let's say 2.5 you have stored there. Then you have the index 1 where you store your second value, let's say 3.5, and things like that, so on and so forth. So there would be as many indexes. There are actually 100 indexes, because here we have the size. It would be from 0 to 99. Okay, so 0 is included. So always whatever the size you're gonna specify, the index would be -1 of that. Okay, it would be one less. So if you talk about how to initialize an array, it is fairly simple. You can initialize it in this way. You can have like here brackets, and then inside the brackets you can have different values. So maybe 3.5, 4.5, 6.5, and then maybe 7.5. So these are like 1, 2, 3, 4, 5 values, and you can actually do certain things with it. So here you can see that we have specified the size, and only we have 5 values in here. And even if we don't want to specify the size, that is okay as well, because it is going to automatically understand that these many values have been entered, so that would be the size of the array. Okay, so that is fairly simple. So now the idea is that for float we have this array, and we can also build an array for integers as well. Okay, so if we talk about the array1 on the 0th index, there would be 2.5. okay, but we have removed that. So the idea is that, let me just give you an idea here, that on array 1 on the 0th index we have 2.5. okay, similarly on the 1 index we have 3.5, and on the 2 index we have 4.5. Okay, now excuse me, on the 2 index we have 4.5. all right, so things like that. You can then have on the 3rd index or the 4th index you would have 6.5, and the 5th index you would have 7.5. So that's how really this array thing works. So let me just remove it from here, and let's do a more practical example in which we could actually learn. So now I'm going to write a program in which I would take 5 values from the user, and then would insert those values in an array, and then we'll basically display it. Or maybe we could take 3 values. Okay, so now first of all, let's say I say int, and then I call the array v or values, and then I take 3 values. All right, so I specify the size, and then after that I have the printf statement. Okay, and inside the printf, what I'm gonna write here is that enter 3 integers of your own choice. All right, so we do that, and after that when they enter, the user basically they enter the 3 integers. Obviously I want it to be saved here, so I want to run the scanner for like 3 times. Okay, so for that, what I would do, that I would just write here integer I equals 0. I would start from 0, then I would put a condition like I is less than 3, so that it would go to the 2nd index 0, 1, 2, and then I would basically increment it. Okay, so this is a pre-increment, and you also have the post increment as well. So post increment means that you basically increment after execution. Pre-increment is that you basically increment before execution of the line. All right, so now in here what we're gonna do is that we're gonna have a scanf command, using which we can basically scan it. Okay, scan the values that we want, and then I'm gonna write here double quote, and inside these double quote, this is an integer, so that's why I'm just gonna take %d, and let's write here /n, and then I'm gonna write here a comma, and after that what I'm gonna do is that I'm gonna write here and then I'm gonna write here v, and in here I'm gonna pass I. Okay, so on one specific index it would keep on saving the value. So for example, when the i's value is 0, on the 0th index it would save 1 value, loop will go on, i's value will be 1, so on for 1 index it would save another value, then it would be 2, and on the 2 index it would save values 3 in total, and when the value would become 3, the loop will break down. All right, so that was fairly simple. Is that we can come here, we can come down here, and in here we can basically write here a printf statement, and we could say displaying integer. Okay, so after displaying the integer, what we can do is that we can have in order to display the integer, we're gonna have a loop here, and that loop would be exactly the same. All right, so let me just copy this from here to here. I'll just simply copy it, and then I change the scanf to printf. Okay, I write here printf, and one more thing that we need to change is this one. Okay, so we just don't need ampersand sign here. It was okay with the scanf sign. Okay, so now we save it. After saving this program, we go to our terminal, and after going to our terminal, we basically just run our program, and when we run it, after that we are just going to go to our output. We hit enter. It says enter 3 integers of your own choice, so we write here 25, 28, 29. We hit enter, and you can see that it basically prints out all those 3 integers, right? So it says 25, 28, 29. These are the integers that we have put in. All right, so if I run my program again, I change
integer to 1, 2, and let's say 5, and you can see that it is displaying those integers 1, 2, and 5. Okay, so that was a fairly simple example of an array. So also what you can do is that you can do an example of basically calculating the average marks of the class maybe. So let's say that we have a class of maybe 10 or 20 or whatever number that you want to say. So we'll just write the code here. Do another little example. We can also do that. So for example, if we have this integer array, and let's say it has a size of maybe 5, and if we have different values here, let's say we have 1, or maybe we have, let's say, 10, 20, 30, 40, and we have 50. Okay, so these are the 5 values of an array, and if we want to print each index, that way you would understand better. Okay, so we have printf here, and inside here we have %d/n, and here we put a comma here, and if we want to print out the 0th index, let's see what happens. So on the 0th index we have 10, on 1 index we have 20, on 2 index we have 30, which is actually the 3rd index, and on 4th index, or on the 3rd number, we have 40, and on the index number 4, or in total 5th, we have 50. Okay, so this should print 10 for us. So we save it. Before saving, we just write here return 0. We put a semicolon here. We save it, we go back to our terminal. Let me just clear it. So we run it, and you will see that there are no errors. Okay, so then we write here, basically run here the output file, and you can see that we've got 10. All right, so in the similar way, if I would write here 1, it would print out 20. If I write here 2, it would print out 30. If I write here 3, it would print out 40. And if I write here 4, it would print out 50. So let's say if I write here 3, it should print out 40, right? So we go here, we run our program, and then we basically run our output file, and we get 40 here. Okay, so I hope you've got the idea. You have learned something new regarding array, and your concepts are more clearer than before. Okay, so let me just quickly print it out for all of that so that you get a better idea. So let me just write here 3, 4, 5 times, and then let me just indentation is not a problem in C, so I would just keep it that way. It really doesn't matter. So if I save it, I go here, I run my program, I run the output binary file. You can see that we have 10, 20, 30, 40, 50, and each of them has been accessed by the index. Okay, so now let's move on to our next topic, which is essentially functions in C. All right, so what we're going to do is that we're going to discuss the functions and the return statements combined. Okay, you can basically divide up your code into separate functions. How you divide up your code among different functions is up to you totally. Okay, so but logically, if you think that the division is such that each function performs a specific task. All right, so a function declaration, it tells the compiler about a function's name, return type, and parameters. Okay, so a function definition provides the actual body of the function as well. So the C standard library, it provides numerous built-in functions that you program. Basically that's what your program can call. For example, string concatenation, memory copy, etc. And a function is also sometimes it is referred to as methods. So you can ask that why do you even need functions? So for example, if you have 100 lines of code, and let's say you have a program having 100,000 lines of code, so what you're gonna do is, let's say that in those 100,000 lines of code, that 100 piece lines of code has been used maybe 20 or 30 times, which means that there are 3,000 lines of code. So each time you're gonna need those 100 lines, you're not going to copy paste all of them. Okay, so what you can do is that you can create a function which you can basically call in one line, and bingo, you have done that just 100 line worth of work in just one line. Okay, so that's how basically this thing works. All right, so if you talk about a function, defining a function, then the function has a basic structure. You're going to have, first of all, you're going to have the return type. Let's say let's see here, if I'm gonna go here, let me just create it for you. In fact, we have this function here which is a main function, so this is a return type of the function. Okay, and the idea is that what other functions you're going to create, you're going to call them inside the main function, because that is the only way you execute and you call them, because in the main block, whatever you have, that would be executed only. Okay, then you have basically the function name. Here we have the main function name, but the user defined function that you would create, basically they could have any name. Okay, so you can name them, you can name that anything. Then in here, inside the parentheses, you have parameters if they are any, so you work with those parameters. So if we talk about the return type, a function, it might return a value. The return type is the data type basically of the value. The function, whatever the value it is going to return, that's what the data type is gotta be. Okay, so some functions, they perform the desired operations without returning a value. These are the functions with void keyword. Okay, so if you just write here void main, then obviously you don't have to return a value. All right, so then we have the function body. In here you can write any code you want. Okay, so now let's just go ahead and let's try to write a function which would return the greatest value. All right, or the maximum value. So let's go here. Let me just create a function here. Let's say we have an integer function and we call it greatest value, or greatest, let's say, and we have parentheses here, and inside these parentheses we're gonna have integer num 1, and then we're gonna have integer num 2. All right, so these are the two numbers, the arguments basically, and in here we're gonna write a code to find that which number is the greatest. So we write here integer result that we represent with r, and then we're gonna have here if, and we're gonna put here a condition. If number 1 is greater than number 2, then in that case what we want to do is that we're gonna put r equals to number 1. Else, if that is not the case, then obviously we know that the number 2 is the bigger one, right? So for that, what we do, we write here r equals number 2. And finally, when all of that is done, we want to return the resulting value, which is essentially r. Okay, if you don't return it, it would throw an error, because the type of the function is integer and it needs an integer value that it would return. So now if we want to call this function, all we have to do is we have to go here and we have to print f, something like this, and inside here what we're gonna do is that we're gonna write here greatest, we're gonna call it, and we are going to pass two values, let's say 3 and let's say 5, and we're gonna print it, okay, whatever the result is gonna be. So for that, we'd write here %d, and bingo, that's it. Okay, so we just save it and we go to our terminal, and let me just clear it. So let's see what happens. Okay, so you can see that there are no errors. So if we run our output file, you can see that we have 5, right? So 5 is the greatest number. So let's swap them. So let's say we have here maybe 10, and let's say we have here maybe 4. So we save it, we go back, run our program, and we try to run our output file, and you can see this time it has returned 10. Okay, so bingo, so we have 10 as the largest value now. So this is how you basically write a function C whenever you need to find a greatest value out of 2. You don't have to write this whole code again and again, this one. You just basically call this function and bingo, you've got the result. Okay, so for example, let's just write a very simple function this time. So let's say that I have a void function, which is, let's say, void printed. All right, and in this void printed, I have a print statement, let's say print f. Okay, and this is like, let's say, hello world, right? Hello world. And let's say that this line, let me just make it look like this. So let's say that we have these these many lines of the code. Okay, so what you're gonna do is that you're not going to, this is just an example. Okay, so you might have different things here. Okay, so let's say that you want to use these lines over and over again. All you have to do is that you just need to call that function here, and let me just write here printed. I called it once, and you can see now, you would see the magic that all of these lines would be printed out. So if I save it, I go back to my terminal, I try to run it, and then I run my output file. Here you can see that we have hello world everywhere, right? And if you just write here, print it twice, like if you just call it once again, you would have the you have the double amount of the output. So I'm not just going to remove it, just in order to show you that. So we'll just write here the output, and you can see that the amount of it has been doubled just because I have called the function twice. Okay, so the same case, it could be a different case, but in a same way. All right, so I hope you understand better, and we have understood the return result thing as well. Okay, so I hope you have got the point. You have learned something new regarding functions. If you have any confusion about functions, just what to do. Just ask us in the comments below, and we'll try to be as responsive as possible. Okay, now let's just move on to the next topic, which is pointers in C. Okay, now let's discuss pointers in C. So pointers in C are easy and fun to learn. Some C programming tasks are performed more easily with pointers, and other tasks such as dynamic memory allocation, they cannot be performed without using pointers. Okay, so it becomes necessary to learn pointers to become a perfect C programmer. Okay, so let's discuss all of that, and let's see what happens with the practical examples. Okay, so as you know, every variable is a memory location, and every memory location has its address defined on the computer in the memory, which can be accessed using ampersand and operator that we usually know of, right? So now let's go ahead and let's try to do the example in which we just do some pointer stuff. Okay, so if we talk about pointers, a pointer is a variable whose value is the address of another variable. Okay, and that is basically the direct address of the memory location. Like any variable or constant, you must declare a pointer before using it to store any variable address. So the general form that you would see of the pointer would be a data type and then asterisk with the variable. So let's say I write here int steric IP. All right, so that would be a pointer. Okay, we have the data type as integer, then we have steric, and then we have the variable name, which is essentially IP. All right, so then you can have, in the same way, you can have the double data type here, and then you can here have a pointer, you can have a float, and then you can have a pointer, then you can have a character, and then you can have a pointer as well. All right, so the type is the pointer's base type. It must be a valid C data type, and the variable name basically here ip is the name of the pointer variable. Okay, the asterisk it basically used to declare a pointer is the same asterisk which you use for multiplication. Okay, however, in this statement the asterisk is being used to designate a variable as a pointer. Alright, so the actual data type of the value of all pointers, whether integer, float, character, or otherwise, is the same. Okay, a long hexadecimal number that represents a memory address. So the only difference between pointers of different data types is that data type of the variable or constant that the pointer points to. Okay, so let me show you that how to use pointers. So there are a few important operations which we will do with the help of pointers very frequently. Okay, so number one, you have to define a pointer variable like we have defined. Then number two, that you have to assign the address of a variable to a pointer, and I'll show you how to do it. And just write here ip, and then you write here equals to, and then you assign the variable that we have not created yet. So let's call it a. Okay, so we can create the variable here as well, a. All right, and finally the third step, you access the value at the address available in the pointer. So this is done by using unary operator static that returns the value of the variable located at the address specified by its operand. So now if you want to, let's say, print out the value of it, so now ip basically it has the value of a. All right, so let me show you that how you can basically print it out. So you can write here printf, and then you can write here the value of steric ip is, and then you can have here this one %t/n, put a comma here, and then you can write here static ip. All right, so what do you think it should print out? So let's see what it exactly prints out. All right, so let me just write here return 0. We are all done. We save it, we go back to our terminal, we try to run our program, and you can see that there are no errors, right? So we just write here the output. You can see that it says the value of steric ip is 22063. Okay, so it's just some sort of garbage value because we have not initialized the variable a. So what we can do is that we can give it a value, let's say 25. Okay, so we save it, and if we go back, we try to run our program again. So this time the result would be different, and that would be the value of steric ip is 25. So in this case we have a variable a, and we have created a pointer steric ip, and we have assigned the address of a to ip, and when we try to access you print the pointer points towards a and prints it value. Okay, so if you write here and ip or and a, it would basically print out the address. Okay, so if we just write ip without static. All right, so now of course you can do multiple things and multiple stuff with these pointers, those long lines of codes. Actually we have used pointers in another course of ours which is like 6 hours long, so I'm going to put the link in the description to that. You can go ahead and you can watch that entire course. After watching, of course, this entire video, you'd understand the basics of C, and then you can go ahead and you can watch that entire video to learn more. Okay, so now you can also have null pointers as well. So it is always a good practice to assign a null value to a pointer variable in case you do not have an exact address to be assigned. Okay, so this is done at the time of variable declaration. A pointer that is assigned null is called a null pointer. Okay, so the null pointer, it is a constant with a value of 0 defined in several standard libraries. Okay, so now the null pointer, the way of defining it is fairly simple. So you just have a steric ip, and after that you would just write here null, and this would be your null pointer, and you can basically use this null pointer for several purposes. All right, So there could be a lot of pointer code examples that we could do, like, pointer array example, return pointer from functions, and, passing pointers to functions, and then pointer to pointer, array of pointers, pointers, arithmetic. We could do a lot of examples. So let's do one simple example, and that is passing pointers to functions in C, okay? So first of all, we'll just have it right here. Let me just remove this. Okay, I remove this. Now I basically create a function here. So I just write here double, and double is basically the function type, and in here I write a function which is, let's call it get av, okay, which means get average, and inside here I pass two arguments, and one of them is gonna be the pointer. So let's call it integer static array1, so which is array1, and then basically I put a comma here, and then I write here integer s. Okay, the s is gonna be size, so let's write size here. Okay, so now what I'm gonna do is that I'm going to write here inside of the body of the function, I just write nothing. First of all, let me just declare it actually. So you declare it first. All right, so this is the declaration of the function, and now I go down here, and here I write that basically the function. Okay, so let me just copy it. I come down here, I paste it, and I create the body of the function, and inside the body of the function I try to write the code. So let's say I have here integer I for the loop, and then I basically define another variable for addition, or I could call it sum, and I initialize it as 0. All right, and after that I basically write here double av or erage for average, and then I write here a colon as well. So I can have float here as well, it really doesn't matter. Okay, so you can have data type as float in average, that would be fine. If you want to have more than 2% letters, like 2 decimal points, if you want to have the result more than that, then you can use double. All right, so once you have that, after that you would have a for loop here, and inside the for loop would basically initialize I. Let me just remove it. We'd initialize I as 0, and then we write here the condition I is less than size, which is basically the second argument, and then we basically post or pre-increment it. Okay, and after that we had the body of the for loop, and inside the body of the for loop we try to write here a sum, and then we write here plus equals, and then we write here the array1. All right, and then we basically inside here we write here the index, which is essentially I. Okay, so this is the index, and now we basically close it with a semicolon. All right, so now if I come out of the for loop in here, I'm just gonna have average. All right, and now I'm gonna write here equals, and then basically I divide the sum with size. All right, and the idea is that sum and size, sum is actually integer, and the size is integer as well, but the double that is average. So in order to deal with that type mismatch, we have to do typecasting. Okay, so typecasting is a concept in programming in which you basically change the type of the variables. Okay, so right now whatever the result we're gonna get in double. Okay, so there was a type mismatch. The average was of double type, and the sum and size was of integer. Okay, they were of integer type, so we have changed the type of it, like from integer to double. So this is called typecasting. Okay, and that's how you do it. So now what we're gonna do is that we're just going to simply return the average that we have got here. Okay, so now what we can do is that we can go ahead and we can call this function inside
the main block. Okay, so if we go inside the main block here we can have something like this, like let's say integer, and then we have marks here maybe. Okay, so let's say that we have 5 students we are going to take marks from. Okay, and then out of 100, let's say first student got 65, the other got 78, this one got 88, this one got like 55, and the last one got, let's say, 68. All right, so now we want to find the average of that, and basically we're gonna pass a pointer of this array through this. Okay, so now what we're gonna do is we are going to define another we are going to define a variable average another time here inside the main block this time. Okay, so here it was basically a local variable, so it is totally fine to define once again here. Okay, with the same name, it would not really make a difference. So now all you have to do is that you have to pass a pointer to the array as an argument. Okay, so what you would do, you'd basically call the function, so you'd write here average, which is a variable in which you're going to store the result. So you'd write here get average. All right, and then you would have parentheses or the round brackets, and inside these round brackets what you're gonna do is you're going to write here marks, okay, which is an array, and then basically you're gonna write here the size of it, which is essentially 7, or maybe I think it is 5. So after writing it, what you're gonna do is that you're going to print it. All right, so now this is of double type, so for that you have %f. Okay, so you write here, for integer you used to have %d, right? So you write here printf, and then you write here the average. Let me just inside the double quotes, the average of 5 student marks is, and then I basically give a space here, and then I write here %f. All right, and in here I'm gonna write here the average, okay, the variable name, and we are all done. So that's how you basically create a pointer and you pass it through the function. Okay, I hope you have got the point. So now if we just simply save it, and if we go to our compiler, maybe our terminal, you can say, we run our program, and you can see that there are no errors. So now if we try to run our output, you can see that it says the average of 5 student marks is 70.80 or 70.80000. All right, so that was the average of these 5 students, and in the meantime or meanwhile what we have done is that we have passed a pointer through a function. All right, so I hope you have enjoyed this pointer thing. If you didn't understand it, you can always ask us in the comments below. So now let's move on to the next topic, which is essentially topic number 18, and that is about writing in a file in C. Okay, now what we're gonna do is that we're going to write in a file. So what we can do is that first of all we can open up the file, and then we can basically take the input from the user, and then we can actually directly write it right on the file. So without further ado, let's go ahead and let's try to do it. So what we would do would go to our program. Let me just remove everything, and I write here hash include stdio.h. This is a header file that we need. Another header file that we need, and that is basically hash include, and then we write here stdlib.h. This is the file that we need for exit statements that we would use inside the code, and then we're gonna have integer main. Okay, and now you're gonna have brackets here, and inside the brackets you can have your code. All right, so let's say that we define a character array here and we call it, you know, writing. All right, so we're gonna write it inside that, so we just assign it a random size of 1000. Okay, so after that what you're gonna do is that you're gonna create a pointer of file type. All right, because that's what we're gonna do. We're gonna write inside the file, and after that we use a built-in function which is essentially fopen. All right, and inside here what we're going to do is that we're going to give the path to the file where we want to write, or essentially if the file doesn't exist, it would create it itself and write into it. And obviously that would happen in the current directory where your program resides. Okay, so if you want to store the file anywhere else, you can basically, you know, give here a path to that file. Okay, so I want to store it on my desktop where my script resides, so I really don't need to enter a path here. I would just write here the file name, which is essentially write.text. Okay, and on my desktop right now there is no file named as write.text, and then I put here a comma, and then I write here inside the double quotes W, which represents writing. Okay, so I want to open a file and then I want to write in it. Okay, and after that what I can do is that if for some reason you know, the user does not write anything into it, I want to print out the error. So I want to have here an if condition, and I want to write here if the pointer it is equal to null. Okay, then in that case I want to print an error. Okay, and if that error is there, I want the program to exit. All right, so I write here print f, and I write here error, or I could write here some problem occurred, exiting now. All right, so after that you can have here exit 1. Okay, 1 0 minus 1, it really doesn't matter. Okay, all are the same. So now we come here, and then what we're gonna do is that we're gonna have here a printf, and in here we say write inside file. Okay, so write inside file, and then basically we have a colon here, we have /n here, and then we have a semicolon here as well. Then we use the gets here. Okay, so in C we have gets and puts. Okay, so gets is for actually getting a value of type text maybe, and puts is of printing it. All right, so now you have here gets, and inside of that you're gonna write here the writing, which is an array. Okay, in which we are going to store it, and then obviously we need to put it inside the file. So for that we just write here fprintf, and in here we're gonna write here fptr, which is essentially a pointer, and then I'm gonna write here double quotes, and then I write here %s. All right, for array. Okay, and then I write here writing. Okay, which is an array. So now what I'm going to do that I am going to close the file as well. Okay, so for that what I would do, I would just simply write here f close, and I would pass the pointer, which is essentially fptr. Okay, so finally I just have to write here return 0, and we are all done. So we save this file, and now I go to my terminal, and let me just clear it. So I ls here, and you can see that there is no you know, write.txt file here on my computer, right? So if I run my program here, you can see that it's like giving me an error because I have put here triple equals, which doesn't make sense. And there is another thing that I'm gonna do with fgets. I'm gonna write here the size of the array, which is essentially 1000, and then I'm gonna write here the standard input. Okay, so we are all done. So now if I save it, I go here, I try to run my program, and thank God there is no error right now. And now I will just go to my flag file, which is an output file. So I hit enter, and you can see that it says right inside the file. So let's say I write here, this is a file and I'm enjoying writing it. Okay, so I hit enter, and you can see that there is no error. So if I ls here right now, you can see that we have write.text here. Okay, and if I nano it right away, write.text, and I hit enter, it would open up, and that's what we have inside the file. Okay, so that's how you basically write a file in C. All right, so now if you want to read a file, I'll show you how. So the idea is that you can pretty much read a file as you have written it, just with a little bit, difference in code. So let's go ahead in the code that we were previously writing, and in here what we can do is that we have here the pointer, we need it, and we're just gonna basically open up the file like this, and instead of having here the W, we're gonna have here R, and let me just basically have it right here. So what we can do is if the pointer is null, we can say some problem occurred, exiting now, or we can say that the file is empty or cannot open the file, or there is like some problem. All right, so the other thing that you could do is basically you can start printing. All right, so the one thing that you can do is that first of all you try to read a content from the file character by character. Okay, so what you can do is that you can have a character variable, let's call it C, and then let me just remove all of that until here, and in here what you're gonna do is that you are going to save it in the character variable that we have created. We're gonna read it. Okay, so we write here f get C, and then I write here fptr. Okay, then I put a semicolon here, and I run a while loop, and it runs it basically until there is no character left. Okay, so I write here C until unless it is not equal to EOF, until unless I want it to keep on printing whatever it finds inside the file. Okay, so we just write here print f. Okay, and then we have brackets here, and inside these brackets we are going to write here double quotes, and inside the double quotes we write here %C, and then we put a comma here, and we write here C as well. We put a semicolon here as well, and after that we'll just go here, we write here C, we write here equal f get C, and then we write here same fpdr. Okay, so it should keep on printing it. All right, so yeah, that was like pretty much it, and after that you basically close the file like we have done it here, and we are pretty much done. So now let's go ahead and let's save it, and let's try to read write.text. So we go here, we try to execute our program, and hopefully it runs without any error. And now let me just clear it. We run the output file, we hit enter, and you can see bingo, this is a file and I'm enjoying writing it. All right, so this is the contents of the write.text. Okay, so if I hit enter, you can see that the same content is in the file. Okay, so that was quite easy, right? So that's how you basically write and then read a file in C programming language. Okay, so alright, so now let's move on to our last but not the least topic, which is making a calculator. Okay, so you can basically add up another topic here as well, and that is basically switch statements. Alright, or you can also call that case statement. So that's what we're gonna cover. Okay, both of them. So Now, without a further ado, let's start it, right? So the idea is that switch statement is like a sort of a case statement where you have different cases, and you can also do the same thing pretty much with if statement as well, if and else. But we are not going to use if statements, we are going to use the switch statement. And once we write it, I'll explain it to you, and I hope you'll understand it in a way better way. Okay, so first of all, what I'm going to do is that I'm just going to remove all of that from here, and I'm going to add one more library. We have stdio.h, stdlib.h, and we are just going to have here conio.h as well. Okay, so now inside the code, what I'm going to do is that I'm going to have here two variables, float x and y, and I'm going to have here another variable which would be result. All right, so the result would have the addition, subtraction, multiplication, whatever the result is, that would be stored in this variable. Okay, then we have a character, and the character choice, let's call it, or maybe selection, it totally depends upon you. Then we have it as ch. Okay, so now what we do, we just write here a simple printf statement, and we tell our user that 1 is for, press 1 for addition. Okay, press 1 and hit enter for addition. Okay, then we can have here /n, which would basically move it up to the next line, and in the similar way we can have it for subtraction, multiplication, and division, because these are the 4 important operations that we're going to perform, right? So that's what we've got to have hit here. Okay, so we just write here, press 2, 3, 4, and we write here for subtraction. Okay, let me just quickly write here subtraction, then we write here multiplication. Okay, multiplication, and then we can quickly write here division. All right, so now what we're gonna do is that we are going to write here the printf statement, which is gonna be like we are going to give the user a choice. Okay, so we write here printf, and we're gonna write here enter your choice. All right, so now when the user basically enters their choice, we make things easier for the user, right? So we basically scan this by using scanf, and we have here %c, and we basically store that in the character that we have here, or we can actually save it inside the character choice. Okay, so that we have created. All right, and then we basically use that inside the switch statement. Okay, so we write here choice, and we are good to go. So now we need to have a body of the switch statement. All right, and inside the body of the switch statement we perform different functions, right? So we have case 1, and the case 1 would be, we just simply print f here, that we basically print f here like let me just write here enter 2 numbers. Okay, if the user has selected the addition function. Okay, so we write here enter 2 numbers. All right, and after that what we can do is that we can put a semicolon here, and we can come here and we can basically scan them. Okay, so we write here scan f, and we can basically write here, because it is a float, so we write here %f twice. All right, because we are scanning 2 numbers and we can scan them in a single line. All right, so we write here and x, and we can write here and y. Alright, so these are the two variables that we are trying to scan. So once you do that, now you go back to your result variable and you write here result equals x plus y. Alright, so you add both of them and then you have the result and you basically simply paste it. Okay, so you just write here printf, and then inside here you write here %f with the result equals %f, and then you write here the variable name, which is essentially result. Okay, then you put a semicolon here, you come here, and after that what you're gonna do is that you're gonna write here a break statement. Okay, so you write here break statement, and now you're gonna move forward to case 2. Okay, so let me just copy this entire case 1 and I simply paste it right here. Okay, so let me just paste it. So it basically moves it forward, so we really don't care because indentation is not a problem in C. So we are here case 2, enter 2 numbers, and you know, we are good. We can just put a minus sign here and we are all good, right? So once you have done that, after that you move along for case 3. So you just basically go down further. Okay, and do not worry if you're not getting it right now, because I'll make you understand you know, step by step and line by line. Okay, so we just write here case 3 and we are good, and in here we just put multiplication, and yes, it is good. So then after that we have case 4 here, so we write here case 4 and we come back here, we basically, you know, bring it down, and then we just simply write here a division sign and we are all done. Okay, so the case statement, it basically, you know, gives you the choice of having a default statement as well. So we just have that, and the default statement says that you did not select the correct option. Okay, so for that we can have here printf, and we can have here, you know, choose the right one please, and that would be like from 1, 2, 3 and 4, right? So put a semicolon here and then we break. Okay, so yeah, that was a switch statement, pretty decent, and we are done with the switch statement. So let me just first explain it to you, then we'll go ahead and we'll try to run it. Okay, so this is a simple calculator that we have created using a switch statement, and remember that we could have done it with using the if statements as well. So first of all, what we have done is that we have created 3 float variables. One is x, the second one is y. Okay, so these are gonna be 2 values that each time we're gonna take from the user whenever we are going to perform a calculation. Then we have this result variable. So if you talk about this result variable, this is the result variable in which we would store the result after performing the operation with those 2 variables that we have here, which are like x and y. Okay, so then I think we did not use ch anywhere, so we can remove it. Yeah, so then we have this choice. Okay, so this is a character and this is going to be used in the switch. Okay, so the idea is that we're going to take 1, 2, 3, 4 as a character. Okay, so then we have the description, or you can say the instructions for the user, so that they know that what to do. Okay, so they have to basically select something, like, you know, when the program would run, they would say enter your choice. Okay, after basically printing this one. So for example, if the user presses 1, okay, so the 1 would be scanned and it would be stored in the choice character variable, right? So after that we have a switch statement. It comes here, so now instead of choice it has 1. Okay.
Okay, so now whatever it is here, it is going to check inside the switch statement. So it comes here and it checks it. Okay, so case 1, it matches right away, so it starts to execute case 1, right? So it comes here, prints this one, enter 2 numbers, you enter 2 numbers, and then it performs the addition and it says the result here. Okay, so we can basically write here addition result. That would be more precise, right? So once it has done it, so for example, after that, after doing it, it would basically break it, and breaking means that it would ignore everything and it comes right out of the switch block, and after switch block we have nothing. Okay, so which means that program ends. So let's say that if the user enters 2, so it comes here, it tries to match it, it is not case 2, so it is case 1, so it ignores it. It comes here, it matches, it executes it, perform the operations, and then it breaks it, ignores everything, comes out of the program. Let's say if user enters the choice 3, it comes here, checks it, doesn't match, checks it, doesn't match, checks it, it matches, it executes everything, and then finally it breaks because of this break statement. And then if the user enters 4, it comes here, checks it, doesn't match, ignores it, comes here, checks it, doesn't match, ignores it, comes here, check it, doesn't match, ignores it, come here, checks it, it matches, and it executes all of that, and then finally it executes the break statement, come out of the switch statement. Okay, and if the user enters anything else, let's say 5 or maybe 10 or whatever, A, B, C, then it comes here, it matches it, it doesn't match, doesn't match, doesn't match, doesn't match. So now what it is going to do, it is going to print out this default statement. It is going to execute this default because none of the case is matching here, and after that it would break out of the switch statement. Okay, I hope you have got the point right here. So we can write here subtraction result. Okay, and here we can say multiplication result. I hope I have explained to you the switch in detail. Okay, but still, if you have any question or confusions, you can always ask that in the comments below. All right, so now if we save it and let's go ahead and let's try to run it, and we go to our terminal and we try to run our program. Actually, we do not really need to use conio.h, so we'll just really comment it because I think it is for compilers. So we'll just remove it. Okay, so we save it and we go back. Let me just clear it. We try to run our program, hit enter, and you can see that there are no errors here. So now we basically run our output file, and you can see that it says press 1 and hit enter for addition, press 2 and hit enter for subtraction, 3 for multiplication, and 4 for division. So let's say that if we want to add first, so it says enter 2 numbers. So let's say we enter 2 and then we enter 3. Okay, so now if we hit enter, you can see that it says the addition result is 5. Okay, and that is right, 3 plus 2 is 5. All right, so we can have like two printf statements, like enter first number and then enter 2, and then we can have 2 scanf statements. It really doesn't matter. Okay, so then we run it again and we run the output file. It says enter your choice. So let's say we enter the second one. So now we are going to subtract. So first is 10, the second is 5, so subtraction result is 5. Okay, 10 minus 5 is obviously 5, right? So then we run the output file again, and then we have this. It says enter your choice. We run it 3, and then we run 3 and 3, and obviously 3 multiplied by 3 is 9. Okay, so we have the multiplication result. And in the same way, if we run our output binary file again, if we select the 4th option and we enter 2 number, let's say 4, and let's say we divide it by 2, then the division result would be 2, because 4 divided by 2 is 2. All right, I hope you have got the point. So now let me just clear it, and if we enter anything else other than that, you can see that it says choose the right one please, 1 2 3 4. Okay, so that's how you work with the switch statement, and you could have done the same thing with the if statements as well. Okay, I hope you have got the point, you have understand it. you have understand everything. If you have any questions, okay, feel free to ask that in the comments below. If you want such free courses coming up every month, then please support us, subscribe to this channel, share this video, give it a thumbs up, just a form of appreciation. And for written articles, you can always visit our website, linuxin.com. Thank you so much for watching. I'll see you in another video.